record. All right, guys. So once again, welcome to Construction Modeling and Simulation. My name is Eric Jindu. This course is about building information modeling. And since you guys introduced yourself, now it's my time. So before I returned to academia, I was working in the industry for several years. I was working for a company called Zachary, located in San Antonio, Texas. And Zachary is building a lot. I saw somebody nodding head. So you know Zachary? Anyway, Zachary is a big name. So they are the top 10 power plant builder in the country. They build a lot of power plants in Florida too. So I was working there. This picture shows I was on the, excuse me, on the job site of Sandy Creek. Sandy Creek is the country's largest coal-fired power plant. And I think the duration for that project was 7 years. So it took them 7 years to build a power plant. They stopped building power plant, coal-fired power plants now. And this picture shows the Dominion gas turbine power plant. So gas turbine power plants are more popular in the US. Basically, this is burning coal, this is burning gas. And the unique thing about that project was they were installing the country's largest fan system. So the huge fans shipped from South Korea, and they basically hoist it up, and the fan is doing the, it's removing all the heat from the system. So this picture shows the Bigfoot project, offshore rig project. So that was in the Corpus Christi, Texas. And if you go closer, that's how it looks like. The cost of that project was $5.1 billion. No kidding, that's $5 billion project. And so by itself, it looks like a 12-story building. But think about that, it got a power plant on the deck. It got a movie theater, gyms, and everything on the power plant, because the offshore rig is a small city. You are building this one, send them to the sea, and you are on yourself. You have to generate power for yourself. So it's actually an amazing small town, and also a small airport. Not airport, it's actually for the helicopters. And this one shows the anchors of this Bigfoot, not the foot itself, but think about this is more kind of like the cables that is tying the Bigfoot. So this is empty in the middle. It sucks out all the air. And so the negative pressure will push down those anchors to the sand. That's how the offshore rig holds itself. But check the size of that. This Bigfoot offshore rig has about like 35 such system to just anchor it in place. A really amazing structure. So this is me when I was young in the home office with my previous co-workers. And everybody on the job site hate home office guys. I don't know if you guys ever interned in a construction company. Usually there's a tension between the home office guys and the job site guys. They don't like each other. So anyway, my company, Zachary, actually forced some home office guys to work on the job site for a month. And I was so lucky they picked me. So they basically sent me to Freeport, Houston, and I worked with the craft workers for a month. I learned a lot of things like how to use chainsaw, how to do the welding. Amazing experience. I almost gave up. I was doing intern at the time while I was doing PhD. So two things in parallel. Actually, I was considering to give up on my PhD after spending a month on the job site. But finally, hopefully, luckily, that experience ended. So I returned and finished my PhD. But you can know why this is interesting. And by the way, guys, there's a reason. The craft workers, especially the welders in Houston, they are rich, because there's a huge shortage of labor, skilled laborers, and the people are paying $60 per hour to hire the welders. And these guys, they only work 6 months a year because the 6 month salary would be enough to support the whole year. So that is actually a nice job. They're the god. And this is me about, let me think, 2013, 7 years ago, when I just started my academic job. And I visited lab at UT San Antonio. So that was my first job. I was an assistant professor at UT San Antonio. And I visited the lab and saw the guy assistant professor too, and all his students were playing video games. So I asked them, what are you guys doing? They said, we are working. So the university is paying us to play video games every day. So anyway, I just told the guy, okay, I want to do the same thing. What is your research area? He said, virtual reality. Then that's when I started to say, I also want to do virtual reality. So I'm doing virtual reality, guys. And this suit is actually something you can see in Hollywood. You put it on, they track the body motion, they reproduce the 3D avatar. And I actually have some interesting video on my personal web. If you search for, I don't know, let's see, ICICUF Eric do, you should be able to see that. Yes, like this. So actually I have a whole bunch of interesting videos, like me controlling the 3D avatar, you know, a lot of virtual reality stuff. If you're interested, you can always go there and check it out yourself. All right, so that's something about me. Now let's talk about this course. Swipe. We're going to have a break, 15-minute break in the middle of the course, okay? All right, question to everybody. When was this picture taken? Unmute yourself, make some noise, guys. I'm afraid.
I would say
1970.
1970, what is that?
1980.
1980s, 70, 80. I heard a lady, oh, we only got one lady. What did you say? Oh, two ladies, right? Yeah. I heard 2000 something, right? Okay. Yeah. You know what? I don't know. I just found this picture randomly online. But here's the story. This is about the construction planning meeting, okay? So this first picture was taken in 1954 when there was no computer. What was this gentleman doing? They were using a piece of paper trying to coordinate the plan of a project, right? And this picture was taken in 2014, about 60 years after this picture was taken. Tell me what these gentlemen were doing. They were still using the same method to coordinate a construction project, piece of paper and talk, right? But think about that, the first man-made vehicle in 2014 was about to leave the solar system. Just think about how much advancements we achieved in other areas, but how the construction industry has been doing such a great job to consistently using low tech, okay? So that's the reality we are facing. All right, guys, name 5 cutting edge information technology currently used in the AEC industry, architecture, engineering, construction. That's called AEC industry. Make some noise, guys.
3D printing.
3D printing, great.
BIM.
BIM, building information modeling, nice. What else?
Drones.
Drones, yes. What else?
Laser scanning.
Laser scanning, all right. What else?
Drones.
Okay, I heard the drones twice, yes. Yes, so what's that? All right, so I think that's enough, right? So let me show you, building information modeling. What's that?
Use of automation.
Okay. Photogrammetry. You know, photogrammetry, any of you knows what photogrammetry is? Photogrammetry is a technology that you take a whole bunch of pictures and you can reproduce the 3D model from the pictures. Okay, that technology called photogrammetry. And we are going to do it. Hopefully we are going to virtually do it together this semester, okay? So we're going to run photogrammetry project. AutoCAD, you know, of course, people mentioned that. VDC, what is VDC?
Virtual design and construction.
Correct, VDC. You know, that's a word that a lot of people tend to use interchangeably with building information modeling, but that one also focuses a lot on construction coordination. LiDAR, you know, laser scanning, that can scan the building. Virtual reality, computerized scheduling, you know, the RFID. RFID, do you guys know what RFID is? You know, it's actually like a patch that you put on your windshield and you can read all the information from your car while you're driving fast, right? And in construction, people attach them to equipment so they can track the information, they can track the location of the equipment, all right? And the drones, right? All right, let me show you when these technologies were invented and started to put in use for the first time. BIM, 1992. Photogrammetry, 1976. AutoCAD 1975, VDC 1970, LiDAR 1963, virtual reality 1968, computerized scheduling, we're talking about the Primavera type of stuff that can run scheduling, 1956. And by the way, guys, the first computerized scheduling happened at Zachary, my previous company. They hired a guy graduated from Stanford University and they made the first program to run this computerized scheduling. RFID 1945 and Joel 1916. And check the title of this page, cutting edge. It is cutting edge to us, to construction, to civil engineering, but not cutting edge at all per se. We are too slow. So when we see anything, we consider them, wow, that's technology. But unfortunately, it happened a long time ago. In fact, if you check the data in the construction industry, this is a survey performed by JB Knowledge. That's also in College Station, Texas. By the way, I didn't mention that I actually transferred from A&M, Texas A&M last year. So I'm still new to Gainesville. So most of the companies, they only spend about 1% of their annual revenue, the construction company, on information technology. We are talking about the LiDAR, software, programs, building information modeling, only about 1% of that. And interesting, about 15% of these guys say, I don't know. What I mean? That means I don't care, right? So I don't know, I don't care. I don't know how much money we spend on technology. It's not important at all. That's the mentality. And talking about IT department, about 2/3 of them only hired about 1 to 5 employees. We know those pathetic guys, right? So if you ever worked for a construction company, they have a very small area for just a couple guys, and they are managing all the laptop issues, printer issues, and also the work phones. I was interning with Kivit Offshore Services, and at the peak time, they had about 3,000 workers, and the home office have about 400 employees, and their IT department only got 4 people. And so for each person, they give you an iPhone, of course, the old version iPhone as a work phone, to think about how busy these guys were. And they just don't care, don't have budget to hire more IT people. Why? When you're trying to sell machine gun to a side of the battle, and their mentality is, I have no time to see a salesman, I got a battle to fight. This is the same thing that is right now is happening in the construction industry. When we are talking about, hey, why don't you use this total station to survey, especially for the drywall subcontractors, the surveying takes a lot of labor hours. So actually people try to sell them the total stations, try to sell them the LiDAR scanner, and just say, sorry, I don't have time to do it. I don't have money to do it. And when you're trying to tell them, hey, that will boost your productivity by 300%, that will save you, let's say $100,000, would you spend $10,000 to buy this piece of equipment? And they always say, no, that's too expensive. So that's the mentality in the construction industry. You have to keep that in mind. And that's probably why we are offering this course here, because you guys will be the future leader. And if you're talking about a change, it must happen because of you guys, all right? I don't think the current decision makers, the current leaders in the construction industry will make the change. I don't think that. I think the change will be driven by you guys. I started teaching building information modeling since 2015. So it's been 5 years every semester, before I moved to Florida. Every time I just told my students that I don't expect you guys to still remember how to build a revenue model. I don't expect after you graduate to still remember where the drop box is, okay? But I expect you to remember the importance of that. I expect you, when you go to your job, you want to become the superstar that can solve a lot of technology issues. And that happened. I know some of my previous students, they learned building information modeling, they go to their office, and all of a sudden they become the heart of information. Why? because if an engineering team have a problem, have a question, they usually think about the BIM guy, because the BIM guy usually has the most information and has the fancy 3D model. And when estimating team has an issue, they go to the BIM guy. Scheduling team have the issue, they go to the BIM guy. Everybody goes to whoever owns a BIM model, because BIM model is so intuitive, is so data rich. You guys know what will happen. Then you will be recognized. And if you are recognized, you will increase, you will be promoted. Make sense, guys? That's actually my personal experience. While I started at Zachary, I'm the kind of, they call me computer guy. So whenever they have a problem, like they cannot connect their computer to a printer, they just they didn't want to create a ticket. The ticket would take them at least 24 hours to receive an email asking them what's the problem. So they usually just came to me and say, hey, computer guy, can you help me solve the problem? You know, of course, you are spending a lot of time, wasting a lot of time doing that. But after a year, I got promoted to the senior level. So, you know, this is actually something you want to keep in mind. Be the guy that can help others. Be the guy that is needed, or the lady that is needed, all right? So the goal of this course is to explore the data-rich, object-oriented, and parametric representation technologies of civil engineering facilities, from which views and information can be extracted and analyzed for construction project acquisition. It's kind of like a bidding, getting a new job, planning, and the controls. Topics include building information modeling for engineering design, model-driven cost estimating, construction operation simulation, scanning and photogrammetry technologies like LiDAR scanning, and also the using picture to create the 3D models, and the advanced topics in construction modeling and simulation. Hey guys, can any of you do me a favor? Make some noise. Just unmute yourself and make some noise. You know, I'm so scared now. I'm not kidding. I'm the only person in Vail Hall right now, and I think I'm the only one living thing in Vail Hall. Okay.
Hi, Professor.
Hello, Professor.
So the learning outcomes, you know, one, to understand the use of building information modeling in construction management. Learn how to create a building information model yourself. So this is what we call BIM for design. You are going to create a model by yourself, all right? Learn how to detect clashes between building components using BIM, which we call constructability review or clash detection. You guys know what is clash detection?
No.
Yeah.
So, okay, so we have somebody knows. Can you explain?
So for example, there is a HVAC duct that is going and it touches the structural column, and we don't know, and from BIM the model we can know that before constructing it actually on the field.
Exactly, yes. Unfortunately, modern buildings are very complex, so none of the design is done by one person or done by one team. So usually you are collecting design from mechanical engineers, electrical engineers, structural engineers, and also architects. The problem is they don't talk to each other. Make sense? That's something you want to keep in mind. In construction business, everybody hates everybody else. Okay, whenever there's a problem, they just basically finger point others. They don't talk to each other. So it's so common that, you know, you have a wall here, but some pipeline guy just build a conduit or something penetrating the wall. Make sense? Or, you know, I have some pictures, I cannot find them now. You know, like you usually subcontract the light fixture to a subcontractor, but for the fire sprinkler, you outsource to somebody else, right? So I have seen many times that the light fixture is here, the sprinkler system is right above the light fixture, right? Because they don't talk to each other. That's called clash. And so BIM is also used to detect the clashes, so we can make phone calls to everybody, say, hey, can you resolve the clashes before we're actually building the thing, all right? And you also will learn how to create a 4D construction visualization model, which we call BIM simulation or scheduling simulation. So it's kind of like animation that you see how this building is built up automatically. And of course, the links to the bar chart, like the schedule, the core of the building. And you see while this bar chart is moving, you see the building is building up. It's really good communication tool. And how to use BIM to estimate project cost, which we call 5D. And this is dual listing course, so we also have graduate students. So for graduate students, you have additional learning outcomes, and one is learn the emerging visualization technologies, such as virtual reality, augmented reality, and also how to formulate BIM-related research. So by the end, all the graduate students will also need to write a research paper, like a research report to talk about what you think about the BIM research and the directions of that, the opportunities of that. Textbooks, recommended but not required. I'm teaching technology. I still don't understand why the university is forcing you guys to buy textbooks. We are in the digital year. We are in the digital era. I don't know why we still force you to buy paper-based materials. But those two books are very popular. One is called the BIM and the Construction Management. The other one is called the BIM Handbook. So like I said, they are not required, but I highly recommend you to either buy them, put on a bookshelf, or to get the digital version of that. Very good books, talking about this life cycle of the BIM. And I provided some reading materials from the books and uploaded them in the cameras already. Computer requirement, I think I talked about that. So for most of Windows operation systems, that wouldn't be a problem. If you're using Apple, you have to add a second operation system, or you can use UF apps. So I uploaded the videos on Canvas, you know how to do it. And this is the software we're going to learn this semester. We're going to learn Autodesk Revit 2020, Autodesk Navisworks Manage 2020, and please note this is not Navisworks 360. Okay, so Autodesk has this goal to move everything online. So they have something called 360. So they move a lot of things like Revit, like Recap, and also like this Navisworks online. But this is not the one we are learning. We cannot use that. The thing we can use is called a Navisworks Manage, not a management, but a Manage 2020. And we're going to learn Autodesk Recap Pro. So Recap Pro is a scanning management tool, and also it supports photogrammetry. So by the way, guys, just give me a second. Let me get something. So I really wish you guys are here, because last year, actually not last year, previously, we always have a lot of interesting game to play. So this is actually a LiDAR scanner. Last year, we scanned the whale hall, some rooms in whale hall, and we sent the model to Recap to clean it up and to send it to Revit. So I guess this year we will just do a live demo. So it's kind of like live streaming. I will have my graduate student facilitate the scan, and it's probably the student will hold the phone, to document the entire process. Mushroom, that's also a scanning management program. Luminant, that's a rendering program. Using Luminant, you can produce the photorealistic 3D model. I don't know if you guys try to buy or see some new houses or apartments. You see those beautiful views or the beautiful 3D models. They are not real. They are actually computer rendered model, and that's actually Luminant is very popular. And we do have free Luminant licenses, but unfortunately, you must have a really strong computer to run that. So I don't think you guys can do it. So very likely that Luminant thing will also be a live streaming a demo. All right. Okay, major assignments and values. So before I talk about that, I want to show you this Canvas system. So this year we try to make the Canvas system very, very student friendly, user friendly. So if you go to the home page, you see modules organized based on weeks. And also you have this welcome start here thing. If you open this one, it basically shows the timeline and the main topics and also deadline for the homeworks. So if you have a question, you can always refer to this page. It shows that I basically highlighted all the deadlines for you guys. So the first homework will be due in about a month, so it's okay. And for each week, if you go there, it talks about objectives for this week. the learning outcomes for this week. And before each class, I also uploaded the notes. For example, here, what you see the course note I already uploaded on Canvas. So if you want to make notes, you can download them, put them on iPad and or use OneNote, whatever, to take notes. And after each course, I will also upload the videos on YouTube and send the link here. So you will get a chance to review that. I have provided the reading materials, but this is only optional. It wouldn't go into your grade, but I still highly recommend you to do it. So this is from the book I was talking about. Oh no, this is from Market Survey. This McGraw-Hill construction company is very enthusiastic about the BIM, and they publish a lot of reports and some interesting reports. So this is actually a milestone, you know, I will be talking about later. And you want to read this one and understand what's going on. For example, one data is very interesting that in 2007, only about 28 of the US construction companies adopted the BIM technology, but that number increased to 71% just in 5 years. That is actually already 8 years ago. So if nowadays, if you are interviewing with any construction company and say, oh, we are very interested in BIM, we are considering to use BIM, you know who they are. They are too slow, all right? So it's pretty much everybody's already using BIM, okay? This is really, really good data, okay? I definitely recommend you guys to check it. All right, and also assignment, I put it here. Like it talks about like, you know, for undergraduate student, this is what you need to do. This is where you submit your model and the due date is here. For graduate students, this is what you do. And I try to share all the information with you guys, for example, like tutorial. For, you know, this is actually the Revit tutorial that we will go over together. I will be sharing my screen and do it step by step. So you guys will follow me do it. And for graduate students, I also prepared additional tutorial about how to trace an existing CAD model. And that would be the assignments to graduate students only. So undergraduate students, you are lucky. You do not need to worry about how to convert a CAD 2D model to this Revit model. But for graduate students, that's your additional learning contents, all right? But for undergraduate students, if you want to do it, you know, it's open to everybody. So like I said, I try to make this user-friendly discussion. You know, we will have a 10% bonus point if you participated in all discussion. It's kind of like a online forum. Like for example, why have been seeing a faster growing interest in BIM in the past decade? You know, just make some comments. And if you can participate in all the 14-week discussion, I see your name everywhere, then you will receive a 10% bonus point. The quiz is actually, you know, it's nothing. It's just it's more about the participation. So same thing, you know, that will go into your bonus point. So that's how each week looks like. You know, you can pretty much find everything here, what you need for that week. Okay, then this is how we will come up with the final grade for you. There's no exams, there's no midterm, there's no final term. There will only be projects for this course. So we have individual projects, the My Dream House project, that's for undergraduate students. So you will be required to design a model in Revit, something you want to leave in the future. Actually, I had a student, he paid a lot of attention. He was so serious about that. And I asked him why. He said, you know, professor, one day when I'm rich, I'm just going to give the design to a builder and to build a home. So think about it, you're actually designing something for yourself. That's not a bad idea. The pop quizzes, this is more about attendance, like I mentioned. That's 10%, that's individual. But all the others will be group, team projects. So we will have the class detection project, construction estimating, 5D BIM project, 4D simulation project, photogrammetry project, and the final presentation. So each of them will be 10% of your final grade. Final presentation will be 20%. So because this is a team project, we will have a peer evaluation. So you will evaluate the peer numbers and give a 1.0 multiplier or lies. So if you don't like that guy or the lady, you can give it any number between 0 or 1. But I guarantee you, if you give your teammate 0, he or she will fail this course. So think about that before you do that, and be nice to everybody, okay? And for graduate students, pretty much same thing, but graduate students will have additional final BIM review paper. So this is more about reviewing the current BIM research and talk about their own thought. Others will be the same. All right. Any question, any comment so far?
Professor, actually I installed the Revit on my laptop. I could run it on my computer.
Great, yeah.
Do I need to install the other software which were listed, like Lumion?
Yeah, later,
now?
yes, not right now. So we will have about a month to learn Revit. So the first month will be only about Revit. So we have plenty of time to install others.
Okay.
And by the way, it's time for you guys to sign up a team. I put it here. So if you go to the home and here, there's a link. Oh, I also see names, great. So we will have teams of 2. So you put your name here and your email there, so you can start forming your team. That's for all the team assignments. All right, so now let me show you some amazing student work and give you, I just talk about that. I want to visualize how the projects look like. So the first, my dream house project, you model a dream home, you submit the Revit file, blah, 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 blah. And on October the 1st, each person will give a 10-minute presentation to the class to talk about a design. I'm going to show you this picture. And guys, I'm just trying to scare you guys because I found this, this is probably the best model, the best presentation for 5 years. So just be ready to be scared, okay? Let me see if we can, oh, here it is. Let me mute here. Mute. Let me fast forward a little bit. Okay, let me stop here. All right, can you guys hear me now? How
Yeah.
many of you are considering to quit this course? Raise your hand. I'm kidding, guys. Don't do that. So let me tell you what happened. Basically, this student created this model in Revit and sent this model to Luminar. And Luminar is so idiot proof. It just basically tell you, give you some suggestions to make colors and texture. If you don't like them, you just right click and change the colors and texture. And all the dogs or the iPads or the beds, those are in the library of Luminar. You just basically drag and click there. And also Revit will also have a lot of such a thing. That's probably why Revit is so easy. It looks beautiful, but it's actually so easy. There's a website called Revit City. And if you go there, go download, here you can find whatever thing you want to find. For example, Star Wars. Let me see, is it Star Wars? No. Let me see. Download. Is that Star Wars or Star Wars? Star Wars? Is there S here? See, you can find whatever model you need. So think about Revit is kind of like playing the game Minecraft. Do you guys play Minecraft? This is kind of like you have a toolbox with a lot of things like walls or ceilings or tables, TV, bookshelf, and it basically just go there and just drag them there. That's how you make a Revit model. It's very different from AutoCAD experience. Did you guys take an AutoCAD class before?
Yeah.
How many of you? Yeah. I remember that when I was taking AutoCAD, when I was an undergraduate student, the final exam is to make a toilet. You know why? Because toilet with a lot of curves. It's very difficult. But making a toilet in Revit, it's just a matter of a second. You just find the toilet, drag it here. That's why Revit is so different than AutoCAD. And you can always downgrade. Like you build a toilet in Revit, you can always print different elevations of the toilet as a CAD drawing. That's the beauty of Revit. So don't be scared, don't quit the course. I guarantee you, a lot of students felt scared at the very beginning, but after just one course, they say, oh, this is so easy. Revit is so easy, okay? So that's the first assignment. The second one, okay, for graduate students, unfortunately, graduate students cannot have your dream. I will give you some drawings, the 2D drawings, and you have to do something called a model tracing. This is happening a lot in the construction industry. A lot of contractors, they want to have their own BIM model for their construction coordination, but the designers actually refuse to give them the BIM model. So they only give them the AutoCAD drawings, and the general contractors will outsource or do themselves to trace the model and remake the 3D model, the Revit model. So that's actually the skill set that is needed. So that's why I want the master students to focus on that. Quick question to you guys. Why the designers don't want to share the BIM model, but only share the AutoCAD?
Because the BIM model has a lot of details in it, and it's like a security reason. And there's so many components that the GC uses that cannot go outside.
But did you ever work in the industry?
Yeah, I worked in industry. I worked for almost 2-3 years in the industry.
Great. Yeah, you just to the point directly. Liability. When you downgrade the dimension to 2D, you can have a lot of potential errors and data. Make sense? When you are sending a 3D model, I'm not talking about just a 3D model. I'm also talking about all the data that comes with the Revit model. For example, the insulation rate of a door, of a window, the material, the PSI of your concrete, the supplier's telephone number. So everything can be stored in the Revit model. If you're sending that, you are running a lot of potential liability issues. Make sense, guys? So, but why AutoCAD? Because the contract only says AutoCAD. I will just fulfill the requirement contract. I don't want to share my BIM model. Same thing happened to, when the general contractor is handing over the final project to a facility manager. I spent $10,000, $20,000 to redo this 3D model. I don't want to share that with you for free. I'm going to print it out as a 2D drawing, and here you are. So that's why I say nobody likes others in the construction industry. Everybody hates everybody. That is our construction industry. But be nice to everybody, okay, guys? So assignment 2, that's clash detection. So a model will be provided. You want to review and the provided model and identify the 10 most critical clashes. Let me tell you how it looks like, the clash detection. And what is clash detection? I think we need to have some music. This is not a good one. Hello? No, it's normal, right?
Yes.
Did that wake you guys up? It did wake me up. Sorry, I'm using 2 computers and it's a little bit confusing right now. Anyway, so let me mute my, oops. Hello? Okay, should be working this time.
Yeah, we can hear you.
Yeah.
All right. Yeah, so I just found this is the program I'm going to use in Navisworks, and this is how it looks like. So basically, you import a model here, and you run this clash detection. So let me see if we can go there directly. And it will tell you where the clashes are, like when this pipeline goes through the wall, or when the levels of a floor is not correct for a piece of machine. That's basically what you can find. Like this is the clash detection window. And just run it. For example, this is one structure versus mechanical. That is very common, structural components and fighting with mechanical system. And you just run it, very simple, EDR proof, and then you define different tabs. And see, now it tells you where the problems are. Now you guys have a sense how clash detection look like, right? If yes, I'm going to stop here. And I'm going to show you quickly the models you guys are using. I try to make this one interesting, so I found a really big model. This is the world's largest grain facility in Vancouver, Canada. So just check the size of this model, I don't know if I can show you this one. This is actually a ship. So they have a very, very, very detailed model. Oh, it's here. And also this model has a lot of underground. Let me go closer and show you the detail of any BIM model can have. Like go closer. Let's keep going closer. You guys see all the details here? Like for example, the connection here. Think about how much information are included in such a model, right? And that there's a building over there as well. So let me go there. If you go inside the building, that's actually, I don't know, like a 12-story building. There are like a lot of things going on. So what I'm going to ask you is to, and also by the way, like I mentioned earlier, there are a lot of underground utilities as well. So let me do this. You see this and all the underground utilities. All right. So can anybody give me a rough number, like how many clashes are included in this model? How many stupid designs we have in this model? Can anybody give me an answer?
1,000.
1,000. What else?
A lot.
What's that? I didn't get that.
Should be more than 10,000.
More than 10,000. Yeah. Who said that?
I guess it's 68, right?
Was that?
Is it 68? It says it's 68.
No, there's nothing showing. It's probably some number. It's probably some number showing the saved views. Okay, let me tell you guys, we don't know how many clashes we have in this model, because every time when we run everything, every single computer just froze because there are so many clashes. But I can give you some understanding. Autodesk provides a default model, a very simple school project, 3 levels. Okay, that's the school in Germany, provided by Autodesk. It's supposed to be a good model, right? That model contains about 3,000 clashes. All right, so we don't know, but it's definitely more than 10,000. It's probably, my guess is probably 100,000. So your task will be very easy. You'll find 10 of them. So, you know, when you run this class detection, you don't run everything against everything. Just basically pick, you know what, I want to run the second level of this building, the mechanical system on the second level. And let me just open this, this selection tree, make it bigger. And also, you know, the structure of that, how to do it. If you open this one, see, this one basically tells you, it's like a selection tree, right? You select that, it will highlight what you are selecting. So now you can basically know what you are doing, what you are trying to connect, right? So this one highlights everything like this. And of course, you can always often, you know, just unfold this selection tree. So you can basically work with your team member, try to see, okay, I'm interested in just that building. I'm probably just interested in the top level, the utilities, the facilities above the ceiling. So now let me try to work on that. That's basically class detection.
Doctor, I have a question.
Yeah.
So is it basically just simulation and creating a 3D model for 2D designs?
No, that's actually the first assignment. This one is the class detection. So what you are asking is actually the assignment 1. I'm going to provide you with some 2D drawing, so you rebuild a 3D model. This one, you do not need to build anything. I'm going to give you this model on the screen, and you just need to run that analysis using Navisworks. All right. So this is class detection. This is how it looks like. And then the next homework. So let me finish all the assignment and we will take a break. So the 4D simulation, you know, once again, I am going to provide you with a model. You do not need to build anything, guys. The only thing you need to build is the first assignment, build a house you want to live. All the others, I will provide you with the model. So I'm going to provide a model, and this is how the 4D simulation looks like.
So Dr. Du, I had a question before.
Sure.
So so for the graduate students, that means we don't have to build anything from scratch, right? So you provide us with the 2D model and we just trace it and build it, right?
Exactly, yes.
Okay.
Yeah.
Thank you.
Actually, that is even more difficult because if you open Revit, this is Revit. I mean, just open this 3D view of that. So project. So if you open Revit, it's actually very easy to just randomly open, like a floor and just go architecture. Yeah. I want to build a wall, and I just basically, boo, I want to do this. I want to do this. Whoa, I'm done. And if you go to the 3D view, see, you just build a wall here. So, creating something from nothing is really easy, right? It's kind of like playing the video game Minecraft. It's actually more difficult to give you a drawing. So that's why it's for graduate students. All the graduate students happy with that? I think so. All right. So this is the 4D simulation. This is how it looks like. Oh, I think I basically make it fast, so it looks really fast. Oh, it's normal. See, that's 4D simulation. It's kind of like you are looking at how the building is being built up. And also it shows the cost over time, the cash flow. And this is not showing the complete picture because you can also see that schedule, the going on, the time is moving. That's called 4D. Really nice, right? So now let me ask you another question. Why is 4D useful? Why are we learning this? Anybody?
I guess it showed the schedule as well, like when what starts.
Yes. So this is a good marketing tool. Like when you are trying to get a job from an owner, you probably have about, let's say 20 minutes, 30 minutes to present your plan. Nowadays, a lot of owners require you to present the plan. So instead of playing the PowerPoint and talking through the project, you can definitely play this 4D simulation. So this is more intuitive, right? So that's how you impress the owner, but that's not everything. Actually, the biggest user of 4D simulation method, they don't list that as their #1 reason. Do you guys know what is #1 reason? Think about that. If you are a general contractor, if you are a project manager, what is the #1 headache for you? You got 12, 15 subcontractors. You go ahead.
The cost.
Of course, yes, cost. But talking about a management thing, what is the biggest thing that make your management so difficult?
Coordinate the different subcontractors and like.
Exactly. So a lot of it, for most general contractors, about 90% of the work are subcontracted. So a lot of general contractors, they only do concrete foundation. They outsource everything else. So you are dealing with potentially more than 10 subcontractors. And like I said, that's the golden rule in construction. Nobody talks to anybody, right? So they don't talk to each other. So that's why you want to play the video and let them know, oh, now we are putting this conduit, so drywall guys don't come now. Make sense? So this is actually the tool for you to coordinate efforts across different teams. That's actually the #1 reason for 4D simulation. Make sense, guys?
Yes.
All right.
I have a question.
Sure.
Is it 4D because you can see how it's being built, or why is it 4D and not 3D?
Oh, the 4D is just a fancy word we give to that. 4D just a 3D plus time.
Oh, okay.
And the 5D, the same thing. 5D is 4D plus cost.
Plus cost. Gotcha.
Yes.
Thank you.
Yes. It's actually not the word created by me. It's the word that is being used as a standard today. So I will be talking about that. 3D, 4D, 5D, 6D, 7D. So we have what we call the 7D BIM. 3D is structure, 4D is time, 5D is cost, 6D is sustainability, and 7D is facility management. So that's basically the additional information layers you're adding to your BIM model. Make sense? For the grammetry project, so build a 3D model of any UF structure. Unfortunately, I don't know if we can do it this year, but any structure, including a dorm room, if you want to do it, using photogrammetry or LiDAR, and just talk about that. Let me show you what that looks like. All right. Not a big deal. For example, like you can use a drone, by the way. You know, your drones take a lot of pictures and you build a fancy 3D model. Let me find a short one. Maybe like this one, okay? I don't understand why YouTube is giving you 2 commercials now.
Yeah, sucks.
And you have to wait. Here we are. You know, this is basically, you know, you take a picture. Definitely you can use a drone, but you can also use your personal iPhone. And by the way, guys, if you guys were here, we are going to fly a drone together, but unfortunately we cannot do it this year. So you basically just take pictures, can be pictures from the drone or from whatever, and you're building the 3D model. So this is a computer generated 3D model. That's called the photogrammetry. We will talk about all the details, the technology behind that. So you just take a picture from different angles. Makes sense, right? So if you take a picture from different angles, you have all the information you need for a 3D model. So you take a whole bunch of them. We are talking about 200, 300 pictures, and they create something called a point cloud. And they basically copy paste all the pictures on top of that. So now you have a 3D model. And this 3D model you can send to Revit. You can measure the length, the area size, the volume. So you can take it, you can treat it as a real 3D model. That's actually so convenient for construction today. Some companies actually use this in a very smart way. They are doing the earth moving. They fly the drone this week, they fly the drone next week. They overlay the 2 models and boom, the volume difference just showing up automatically. You do not need to do any calculation, it tells you directly. That's photogrammetry. Make sense? And this is, let me see here. This is what we did last year. You know where it is? UF. So we basically went to one of the drill ground and we flew the drone together, everybody. I asked everybody to fly the drone for like 2 minutes and they were excited. And this old video shows I was flying the drone with students at Texas A&M. Very stable. That was a windy day, I remember that, but HD 4K. The drone can take 4K video, okay? You guys see how steady it is? This drone actually has a really fancy chip card that can stabilize itself based on the posture. So even though it was a windy day, you can see, okay, let me just move that a little bit here. I'll just watch the flags, okay? But see how stable the drone is. It's kind of like the drone, it's kind of like you are taking this on top of some tall building, right? No, it's actually by a drone. That's Texas A&M, that's Car Station. Let's see what else we have. Oh, that's the Kyle Field, the stadium over there. I'll see that wind, the propeller. Yeah. And now it's descending, and you will be seeing just me soon. And all the students are on the ground. Okay, landed. I think I have some interesting video that I flew the drone and created a 3D model. So after that, we'll take a break, guys, I guarantee you. Let me see, video. Here it is. So this is a fast play. So we basically, this is the Francis Hall on A&M campus. So I just flew it. I just fly it and I took a 5-minute video and I sent the video to a program. The program basically cut the video into pictures, the 4K pictures, and generated the 3D model of Francis Hall. It happened within 5 minutes. Okay, think about that. That's the 3D model I created from the Zoom video. And I send it to the Revit and I measured the volume and area size of each facade of Francis Hall. All right, this will be something we are going to learn this year, all right? So I think that's pretty much, oh, just let me finish this part. The assignment 5, construction estimating using BIM. So we're gonna use a tool called, okay, anyway, let's take a break and let's talk about that later. So, okay, so let's get it back at 5:43, all right? See you guys then.
Okay.
Okay.